Welcome back to the channel. So last time we finished up the flywheel and also put a set screw in it. So I've got that all mounted now. Everything is working good. And I also honed the cylinder. Just honed it with a 3-stone hone. And the next thing we're going to start making is the piston. So I've got a chunk of aluminum here to start with. It's a little bit bigger than what we need. First thing we're going to do is turn it to size on the lathe, and we want it to be roughly 2 thousandths smaller than what we ended up with here on our bore. So we got a nice tight fit. And then we will counter bore it on the ID here, and then we will cut the ring grooves in it. So that will allow me to use a tool that I made here a while back. So it's a tool holder that holds around 3/16 just high-speed steel bits. And I already had this shank, so I made this chunk of metal here and welded it to it, and then took the slitting saw and cut it, and then drilled and tapped it for a set screw, for a socket head cap screw. And then you can just grind the tool into whatever kind of shape you need. This one is a 40 thousandths groove tool or cutoff tool, but you can easily just take this out, and then I'll cut these off shorter because you don't need that much length on them. So you can make 2 or 3 tools out of one piece, and these are pretty cheap. So you can grind it into any kind of tool you need to make a profile or whatever. I saw this idea on the internet. I can't remember exactly where I saw it at, but I thought it was a good idea, so I made one. But this will allow us to cut our ring grooves in the piston. For the rings, for this engine, I'm going to use an O-ring. This is a Viton O-ring, and if you're looking for one, it's a dash number 18. This particular one I got from McMaster Car. I've made some engines with the O-rings in the past, and they seem to work good. It seals up good, so we're going to give that a try. First, if you're making cast iron rings or purchasing, there are some suggestions in the plans in the back of where to purchase cast iron rings. So there are some commercially available rings. So once we turn this down, we need to actually machine out a pocket on the inside, and then we also need to drill and ream it for the pin bore. So to do that easier, what I'm going to do is put it in a 5C collet block, and I've got a 1-inch 5C collet in here. So we'll turn this down before we part it off, and we'll actually leave it long to start with. So we'll leave a little stub here that's 1 inch long, so we can put it in the collet block, and then that will allow us to set it up here to machine out the pocket. And then once we turn it down and we drill and ream our hole for the pin bore, we know that it's perfectly perpendicular to that pocket that we machined out for the connecting rod. We can also, in this orientation, we can drill and tap for the 2 set screws that hold the pin. So this will just make it easier to set up, and once we get all that machining done, then we can put it back in the lathe and then just face off the little nub that we leave on there to hold it with. So we'll go ahead and get this set up in the lathe and start machining on it. Okay, so we got all the lathe work done on that. Got it turned to size on the OD, and it's a good fit in the cylinder. We got the groove in it for the O-ring, and then we bored it out with an end mill, 3/8 end mill to the depth, and then took a boring bar, machined this out 250 deep to a 750 diameter. So the next thing we need to do is finish machining out this 3/8 section to a slot. And then we need to drill it and ream it for the pin. So this is what I was talking about on this. I left a 1-inch stub on the end that I can put in this 5C collet block. So then we can clamp this down. We can put this in the vise, find the center, find our position for our pin. So then we can drill it and ream it for the pin. Then we can flip it 90 degrees either direction to put the hole, and we're still on center, so we can put the hole for the oiler. There's a little brass tube that gets pressed into here for the oil. Then, because we're still on center, we can flip it up, and then we can machine this slot out. And then we'll know that this slot for the connecting rod is exactly perpendicular to our pin board. So it's just a handy way to set everything up and know that you're still on center and 90 degrees and hold it. And then once we get all that done, then we can cut the stub off of the front, and then we'll be done with the piston. So we'll get this set up in the milling machine and start working on it. Okay, so that finishes up the machining on the milling machine for the piston. So we got this pocket here machined out. We got it drilled and tapped for the set screws. Then we've got the wrist pin hole drilled and reamed. And then we got a hole drilled and reamed for the oiler. So the only thing we still need to do is we'll chuck this back up in the lathe once I get the lathe set back up, and then we'll part this off here, and then we'll be left with our piston. So before we do that, while I've still got the milling machine set up, we're going to start on the connecting rod. So I got this piece of scrap metal here that I've laid out some lines here. This is going to be the rod here, so we'll bandsaw this off here and here on the end, and then I've got just one hole marked here, which is the big end of the connecting rod. So we'll put this in the milling machine in the vise. We're going to put it on a fixture plate, and then we'll drill and ream this hole, and then we'll move with the DRO up here to drill and ream this hole. So once we get these holes drilled and reamed, get this cut off, then we'll machine it flat, which a lot of it's going to get machined away anyway. We'll just kind of rough it down, and then I'm going to take this scrap piece that I've got here that I used for another project, and I'm going to make an arbor, 1/4 inch on one end and then 3/8 on the other end, so that we can stick this through here and put a socket head cap screw on the top. And then this end here is 1/2 inch. We can then put that in a collet on the rotary table, put this in the vise, get everything centered up, and then we can round these ends off here for both ends of the rod. So the full end will get rounded off, and then it'll get rounded off just a little bit up in here. So it's already the right thickness here. It's 5/16, but it ends up 1/4 inch in the middle. So that circle that we machine, it'll come all the way around here on the inside. But first thing we'll do is get this set up on a fixture plate and get both ends drilled and reamed. pretty good. I was able to chuck the piston back up in the lathe and get it cut off. So we're done with it now, except for putting the oiler in it. Then I got the connecting rod started, machined. So I ended up setting it up in our fixture, this fixture that I have, and I was able to set it up at 1.5 degrees, and then go ahead and machine it out on the sides. So I went ahead and did that while I had the milling machine set up. And then I made the arbor that we talked about to go in here for the rotary table. So I was able to set that up and round off the ends, both ends here, and then round this off, cut 31 thousandths off of both sides. So next thing we need to do is set this back up in the milling machine and go ahead and thin this middle section out to match these ends, and then we'll blend everything in, and then we'll be done with the connecting rod. So next time we'll do that and then make the bushings and press and Loctite the bushings in the small end and the big end, and then it still gets drilled in this small end here for an oil hole. And then we'll also make the brass piece that gets pressed into the piston for the oiler. So that drips oil down onto the hole that we'll drill here, which will lubricate the pin. And then we'll also make the wrist pin next time. Then we can put it all together, and we'll make the grease cup here that holds the connecting rod on, and then we can put it together and rotate it over. Thanks for watching.